Question number 1. Explain why shielding is more effective by electrons in a shell of lower principal quantum number than by electrons having the same principal quantum number. So here shows a comparison of radial distribution function of 1s, 2s, and 2p. And it's clearly that a 1s orbital has a higher probability of being found between the nucleus and the electrons than 2s and 2p orbitals, and therefore it's more effective in shielding. Question number 2. The effective nuclear charge seen by a 2s electron in Lydian is 1.28. We might expect the number to be 1 rather than 1.28. So why is larger than 1? Now for Lydian, it has 3 positive charge in the nucleus and 3 electrons outside. If 2 electrons in the 1s orbital and 1 electron in the 2s orbital, and if the 1s orbital is completely inside a 2s orbital, then you would expect the electron in the 2s orbital can only see charge 3 minus 2, that's 1. However, the 1s orbital is not completely inside 2s orbital, and the 2s orbital is not completely outside 1s orbital. The orbital is a wave function, and you can see again in this diagram that even though 1s orbital electron has a high density closer to the nucleus, the 2s orbital also has a probability that close to the nucleus. It has a subsidiary maximum that close to the nucleus. In other words, the electron in 2s orbital can penetrate through 1s orbital, and therefore the effective nuclear charge seen by the 2s electrons is reduced by a number smaller than 2. Question number 3. Write the ground state electronic configuration of D metals from scandium to zinc. As I mentioned in class, these transition metals, they have electron already filled the first row, the second row, the third row up to 3p6, and then 4s2, and the actual electrons goes to d orbital. So for scandium is 3d1, for titanium is 3d2, vanadium 3d3. Now chromium is an exception, so you would expect chromium goes to 3d4, but instead one electron go from 4s orbital to 3d4, it becomes 3d5 and 4s1. And then magnesium goes to 4s2 and then 3d5. And the next 3d6, 3d7, 3d8, and now here comes a second exception. Now instead of 3d9, it goes to 3d10 with 4s1. And then zinc, 4s2, 3d10. Question number 4. How many electrons can occupy subshells with L equals 3? So L equals 3, M can be 0, positive, negative 1, positive, negative 2, positive, negative 3. In other words, there are 2L plus 1, which is 7 orbitals, and therefore the total electron is 7 times 2. Each orbital has 2 electrons, so it's 14 electrons. Question number 5. Why the electronic configuration of each CHEM atom is 4d1 5s2, and silver atom is 4d10 5s1. In other words, for each CHEM, it fills the 4s and then goes to 4d, but for silver it goes 4d 10 and then 5s1. Okay, why is the difference? So the reason for each CHEM to be 4d1 5s2 is because even though the d orbital has a lower energy than s orbital. The 4d orbital is more closer to the nucleus, so the electrons in d orbital will suffer repulsion force, and therefore, to minimize the energy, the electrons fills the s orbital first, and then goes to the d orbital. Now, for silver, okay, it can achieve extra stability by full filling of the d orbital. Okay, so that it has more parallel spins, and that can have extra stability, and therefore it goes to d orbital, becomes 10, and then the electron goes to s orbital. Question number 6. It compares iron 2, iron 3, and asks you which do you expect to be larger, iron 2 or iron 3? Okay, so iron 3 has a higher positive charge than iron 2, and the positive charge higher, that means the electron feels more attraction force to the nucleus, and then iron 2, and the larger the attraction force, the smaller the radius, and therefore we expect iron 2 has the larger radius. Next one. So consider the atoms of period 2 elements of periodic table. Predict which elements has the lowest first ionization energy. So period 2 start from lithium, and then beryllium, and then goes to neon. Okay, and as we know, across the period from left to right, the effective nuclear charge increase and the radius decrease, and that means it takes more energy to remove electron from the atom from left to right, and therefore the lowest ionization energy should be lithium. Question number 8. Identify the levels of configuration P1. Now, if we have electron in p orbital, first the electron will have orbital angular momentum, and the orbital angular momentum quantum number L equals 1. And the electron also spin with two states, alpha and the beta state. And so when they are in the same direction, the spin orbital coupling have a J 1 plus half, and they were in the opposite direction is 1 minus half. So that gives you half. And the energy of these two states can be calculated by the equation we introduced in the class. So here is the coupling constant, and the J quantum number, and L quantum number, and the S quantum number. So these are the two energies of the two states. So the electron in a p orbital is split to two levels due to the spin orbit coupling.